I want to say thank you to all of the sponsors who helped make this possible. I wish I could be there in person, but I decided the next best thing was to wake up at 4 a.m. to give a presentation. So let's do this. If you have any questions, let me know at any time. I'm happy to take them. This is going to be a very packed session, however, so I'm probably going to have to talk a little fast to make sure we get everything done in time. My name is Kevin Feasel. I'm a Microsoft Data Platform MVP out of Durham, North Carolina. I also run a predictive analytics team, and I have a blog called Curated SQL. The idea of Curated SQL is I try to find 5 to 10 links per day on topics all across the data platform and share them. So that's curatedsql.com. What I'd like to do is help walk us through the process of minimizing downtime due to application deployments specifically. In an ideal world, we would have 0 downtime due to application deployments. In reality, that's impossible, and I'll talk about why, and we'll settle for asymptotically approaching 0. So, like I mentioned, there's a lot we're going to cover. The first thing I want to hit is the concept of downtime. I used to work for a government agency for one of the states in the United States, and we had a timesheet application that we had to, like, every week they would do payroll. A different agency handled this application. We didn't own it. And that application went offline Friday at about 4 p.m., and it came back online about 9 a.m. on Monday. It was also off overnight. So basically, they would shut the application off for external users overnight for processing. Well, since then, I don't think I've run into a website that actually has office hours like that one did. But if you do, great. Downtime's not really a problem. You can enjoy that downtime and do all of your deployments then. Today, I work for a company that runs 24/7. We do e-commerce across the globe, and as a result, we really can't be down. Most websites are like the latter example. People expect this thing will be up, even if they're coming in at 4 a.m. and checking out your site. Users can expect some degradation, especially around performance, and that's generally okay, depending on the extent of that degradation. But if your website is just down, especially if you're fairly popular, they're going to stop going to your site pretty quickly. So we don't want to have those regular downtimes in order to deploy out our code. Defining downtime. This is any time users are unable to access the resources they need in your product. So I made this purposefully vague because there's a lot of reasons why a person might experience downtime. And from my perspective as a user, I don't really care what the reason is. It could be that hardware's failed or you're doing a deployment. It could be networking issues. It's always the network. Always blame the network people. It could be that somebody's got a lock on some resource, or there's even persistent timeouts. I can't tell you why your website's not working, but I just see that your website's not working, therefore it's down. So it's a very simplistic approach, but it's the one that users do take. And we're going to focus on that second case, application down due to deployment. All of those other scenarios, important scenarios that you'll want to work through and work with high availability and ensure that you have appropriate network resources, et cetera, et cetera. Here's why I said we cannot have absolutely 0 downtime. A table lock is technically downtime. If you lock a table for, an hour as you go to lunch, if it's your big fact table in the data warehouse and nobody else is able to access the data, you're going to hear complaints. That's my rule of thumb for, do I experience downtime? If the resource goes down and you start hearing complaints, yeah, that's downtime. Many operations will take locks. Those locks generally are very short. It could be a few milliseconds. If it's just a few milliseconds, people are not going to notice the locks. But technically, that's a little tiny bit of downtime. And every once in a while, you might get something that instead of a few milliseconds, it's locked for 30 seconds. and that might cause a timeout for some query that just happens to be running, waiting for that resource. If it's just a couple of seconds, though, we have a built-in excuse. I'll just blame the network. The networks must be just slow today. So um, that's my second rule of thumb. If you can comfortably blame the network, it's not really downtime. So that's where we want to get to, where we could, during deployment, say, oh, that must just be the network's fault today. It's a little slow. Give it a time and it'll be fine. And what we can do here, by following some practices, is get to a point where users are able to get their work done with fewer interruptions. We don't shut down the website at 4 p.m. or 6 p.m. because office hours are over on the website. If a person logs in at 10 p.m. because they have to get that work done for the meeting tomorrow, then it'll still be available. And we could still deploy during that time. It might be slightly slower for them. Developers can also get to a point where they're deploying smaller changes faster. And that increased velocity means end users get their fixes sooner, and the changes and the accompanying downtimes are usually smaller as well. Administrators have the benefit of they don't have to wait until 3 a.m. to do a deployment. They can do a deployment anytime. And where we're at, we have deployments that just run throughout the course of the day. Actually, our preference is deploy through the day because now we know that people are in the office in case something fails. Previously, when I started work, we would come in at 5 a.m. on a Tuesday, the first Tuesday of the month, in order to get this deployment out. And basically, we had this 3-hour window where things could either be down or degraded, and we would take up that whole window. Today, no, it runs through the course of the day. Nobody cares. As long as your code works. So let's talk a little bit about how we can get there from the database perspective. So our flow will follow a pattern called the blue-green deployment method. And it's got 4 phases for deployment. First is database pre-release. Then we have the database release. We have the application release, database post-release. In the pre-release, this is going to start, frankly, whenever you feel like it. It could start right now. We may have a deployment a week from now, but if we have a lot of data that we need to work with beforehand, we can schedule this out over the course of the week and do whatever pre-processing we need. So this might be, say, changes that are preparatory for a massive change. If I need to restructure tables, I can start loading data into the new table from the existing tables while people are still using the existing tables. The important thing is users should never actually realize that you're in database pre-release. They're still accessing old code, they're still using old processes, and it might be a tiny bit slower for them. But that's about the closest that you could get in terms of realizing that, oh, you're actually doing a pre-release. The release itself, often it's on a fixed schedule, but we can run it several times a day. We could run this every half hour, every hour. During that time, there might be a slight degradation of services where we're taking locks for a few milliseconds and doing some work. During this phase, we're going to push most of our database changes. This is going to be, say, procedure changes. This is going to be changes to views, adding columns to tables, that type of operation. And our database changes are going to need to support our application because the application hasn't been released yet. After the database changes are in, now we can support the new application. This is a blue-green approach where we're going to show how we can have old and new code running at the same time and still be able to handle both scenarios. So before the release, we have old code, existing code that's running on all of the servers. So this is how it looks right now. I'm going to take down a couple of those servers. We still have enough capacity to handle all of our users. It may be slightly slower, but we assume that we only need 2 of the 4 servers to handle our current workload, which means you might not do this on the busiest day of the year for your site. Then we're going to install the new code on those servers. We're going to run whatever tests we need to run to ensure that the code did deploy successfully. We have all of our unit tests. We may have smoke tests that get run just to make sure that, yep, this app looks okay. What this means is that if I have stored procedures that the old app is using and the new app is using, I have to make sure either that the procedure is compatible across both code bases or that the old code base and the new code base use different stored procedures. We'll talk in more detail about what that looks like in a little bit. But conceptually, I've got to be able to support both old and new code. This way, I don't have a period where the entire app is down. So things are running in parallel, and we might start out where 99% of the people are still on blue. They're still on the old path, but then we start moving people over to green, over to the new code base. And if that doesn't collapse due to some issue that we didn't find, great, we can continue moving people over until we're comfortable. And then we take down the old servers, we install that code on all of the servers, and now we're running everything new code. So over the course of this process, we have a couple of phases where there can be degradation from the applications side due to we have those procedures that were needed for the old code. We can get rid of those. If the new code does not need them, we can get rid of it. This is where we can drop columns, where we can drop tables. This is where we get to destroy the things that are no longer necessary to support our applications. Database post-release can go on for as long as you need it to. Again, customers shouldn't notice that you're doing this. So how do we improve our lives if we want to adopt this approach of blue-green deployments and multi-phase database release process? Well, a couple assumptions. Number one, your code is in source control. And by code, what do I mean? I mean tables, procedures, views, functions, reference scripts if you have reference data. You want to make sure all of this stuff is available in source control, and it's going to be tied to an automated release process. I don't really care what release process you use. If you're using Azure DevOps, if you're using GitHub Actions, if you've built Jenkins servers, if you've got custom release processes, whatever release process you use and whatever continuous integration pipeline you use, doesn't matter. As long as you understand how to use it, as long as you're comfortable with it, then it will work. So we've built our own release process over time and have integrated it in with Azure DevOps. You could certainly do different things. I've worked in other organizations where I do it through GitHub Actions. So basically, as long as you've got some sort of process that can deploy code regularly into dev environments, into production environments, staging environments, if you're able to get that working, you're going to make life so much easier for yourself. The reason is that we can check code into a QA branch and just have it deploy out to a QA environment on a regular basis and have it rerunnable and test that this will work the first time we run it. It'll work the second time we run it. Because in the event that there is a failure, we may be left in an inconsistent state. If we fix the failure, if we fix that bug and deploy out, I want to make sure it doesn't break something else along the way. So source control, my slide says it's not mandatory. Me personally, I'm going to say it's mandatory. My slide is much nicer than I am in this respect. It is really helpful. This is a safety net. If you have a failure, if you have some sort of problem in the code, I can go back, pull it out of source control, fix it, deploy it. You can use whatever you want, but nowadays everybody's using Git. I was always more of a fan of Mercurial, but unfortunately, Git has apparently won the day. Then for release processes, like I mentioned, Azure DevOps, Octopus Deploy, Jenkins, whatever you want to use. the tool itself is not as important as the process and the people who are working with the tools. Humans make a lot of replication mistakes. Machines make many fewer replication mistakes. And therefore, anytime we have repetitive actions, that's where we want to bring in a computer. And that continuous integration pipeline makes sure that we can get out to those other environments repeatedly, because that's going to give us more confidence that when we do go to production, everything's going to move smoothly. In addition, a few recommendations that I have. Now, these are softer recommendations, but they're still useful. Enterprise Edition offers up certain capabilities that you're not going to get with Standard Edition around, say, online index rebuilding, which, by the way, index rebuilds can be downtime if they're locking your table from activities while you're doing this rebuild. That's downtime if people want to use that table. Read committed snapshot isolation can prevent writers from blocking readers in most circumstances. And if somebody's writing, like for example, if you're writing tens of thousands or hundreds of thousands or hundreds of millions of records as part of a deployment process, and you're not using read committed snapshot isolation or something that is snapshot isolation, then you run the risk of blocking other people who are trying to access that table at the same time. And again, if I can't access the table, if I get a database timeout from the perspective of me as a end user of your application, that's down. Using stored procedures, something that I definitely recommend, and I think it makes the process simpler for deployment, but it's not mandatory. You can get away with ad hoc code being written from the application and sent over. It just makes life harder. Database tests at least help you understand if your deployments are going to break the world. So, very quickly for the slides, Enterprise Edition also allows you to do table partitioning and have a little, or be able to have multiple partitions on a table and swap those out very easily. So it can make a deployment easier. Mentioned recommitted snapshot isolation. The downside is that it will increase tempdb usage and can considerably increase tempdb usage. I don't think I've run into a scenario in the last decade or so in which recommitted snapshot isolation was a net negative for an organization. Obviously, there are cases where it could be, but I think it's a very safe default at this point. Stored procedures. The reason why I like stored procedures so much for this purpose is they act as an interface. And for the developers in the room, yeah, that kind of interface. So, developers program to interfaces because it allows them to abstract away the specific concerns of the code and say, I can change the internals of the code without breaking how you interact with it. The same thing with stored procedures. A stored procedure has a signature. It has the inputs that it allows. It has the result set that it'll output, that it'll emit. And the internals of how you get from those inputs to that output should be internal. The application shouldn't care about that in an ideal world. So I may have a stored procedure which is a little bit slow. I can refactor it, meaning I don't change the inputs, I don't change the outputs, I just change the internal processes and maybe make it faster. And as a result, the application doesn't have to change, but we get that benefit of code updates. So we can change database code, change database objects. Like for example, part of the refactoring might be I need to take one table and turn it into two tables. As long as I'm using stored procedures to access that data, the only thing I care about is making sure that the stored procedures don't really change their signature. Otherwise, it doesn't matter how many tables are underneath or how I access them. And database testing, just give you some extra confidence. So T-SQL-T is going to be the most popular database test library out there. But frankly, if you just have a bunch of application tests, in-unit tests, or X-unit tests that are making stored procedure calls, that can be good enough. All right. Now we're going to get into the fun section. So that first 15, 20 minutes was really to give you the concept, the motivation, and the principles. At this point, what we're going to do is dive into a whole bunch of different scenarios. And I'm going to jump to Azure Data Studio. And we're going to live in here for a little while. So let me run my prep script. What the prep script is doing is it's creating a database called ZDT. And I'm adding some data so that we can try things out. If I want to create a new stored procedure, I can use the create or alter procedure syntax. This was introduced in SQL Server 2016, and it allows me to create a procedure, incident code _ get incident codes. And then I'm going to run this during the database release phase. In the code release phase, that's where we deploy our application that will make use of this procedure. And I'll be able to call that procedure and get back different incident codes for, this is crime data in Raleigh, North Carolina. Great, pretty straightforward. So let's say I need to add a new column to that stored procedure. Well, when you're adding a new column to a stored procedure, most of the time, it's just as simple as add that column. And let me show you what I did. We had Raleigh 2014.incident code in 3 columns. I wanted to get incident type name from the incident type table, so I can make this alteration to the procedure. No big deal. Most of the time. If you're working with very old code bases, there is a chance that they are using numeric IDs to represent column numbers. So if you're using like the old ADO code, so if you've got some VB6 code or early VB.NET code or early C# code, first, wow, that's kind of impressive. Second, if it may be using the column number 0, 1, 2, 3 to represent a value. In that event, you would want to add the new columns at the end so that your old code is looking for 0, 1, and 2, and then you have 3. Any code written in the last, say, 12 to 15 years on any language that I'm familiar with is going to allow for either auto mapping or for a dictionary-based lookup where you would say like data frame and then in brackets and quotation marks the name of the column. So if you're writing in that pattern, you can add the new columns anywhere in the script. If you're using the older pattern of ordinal basis for columns, you would want to make sure you add them to the end. Now let's say I want to do the converse. I want to remove a column from a stored procedure. This is not as easy because your code is currently expecting a column. So by taking it away, we're going to break that code. Instead, we create a new version of the procedure. New version exists. It's going to have just the columns that we need. So what we took out was incident description. We said, we don't need that anymore. And I'll deploy the new version of the code. The new application code is going to call 0, 1. And then after the new application code is all the way out in our post-release phase, we can drop the original. All right, so let's say I want to change an input parameter. Well, so far I have no input parameters. And one rule of thumb is if you change the signature of a stored procedure, you're going to want to version it. The exception is if you're adding a column at the end of the output result set. But here I'm adding a new input type ID. Most interfaces are not going to like the fact that we have a new parameter in here, a new input parameter. if your code is generated in such a way that it doesn't care, especially if I do have a default here, um, great, then you don't need a version. But most code bases that I have seen do require versioning, adding a new version of the procedure, and specifically referencing this incident type ID, even if it's just to pass in null as a input parameter. So if we do need to use this, then version the procedure, and in the code release, we have the application call 02 instead of 01. And post release, we can drop 01. What if I'm using a table type? So let's say I create a table type called incident type, and it takes in an incident type ID, which means I can search for multiple incident types. So in that case, I create a new procedure that takes in incident type as a read-only parameter, as a table value parameter, and I deploy this code out. Let's say we've already done that. This ran, it's out in production today. But we realize, we have incident type ID, and I know that I need to include incident type name. But the thing is, our code actually has a lookup list that includes incident type ID and name. So we don't need this join. This join is very expensive. Well, what are we going to do? You can't alter a type. We could drop and recreate the type, but then we may have breaking changes. So I'm going to create a new type. New type, incident type 01, that includes the description as well, or that incident type name as well. And my procedure change, because this is a new table type, I want to create a new version of the procedure. The reason, again, is many times your application code base is going to need to understand that it's using type X versus type Y. And so the application code changes. If you're in a scenario where you don't need to make that change, great. Don't worry about versioning the procedure. Just create the new table type, alter the procedure, and switch over to the new table type. Most of the time, though, application code does need to change, and therefore we version the stored procedure. So as we version the stored procedure, we can remove that join to incident type because we have it already in our input. In the application code release phase, we just drop out that new type and procedure. And in post release, we can drop our old procedure and then our old type. And you have to do it in that order because there's a dependency. So if you try to drop the type first, you'll get an error. And if I run this, everything ran successfully, and we now have our new type list 01. Finally, for procedures. What if I want to refactor a procedure? Definition of refactoring, I don't change the interface. So get incident code 02 had incident type ID equals null, and it did some work and it returned some result set. Well, here I'm modifying the internals of our stored procedure. I've added a comment. I'm changing some stuff around in here. And as long as I do not change the input signature or the output result type, the result set, I can make whatever changes I would like within the context of this procedure, and application code does not change. So there is no application release phase. This is great because it means we can tune queries. We can do a lot of internal work without affecting the application itself. So that's stored procedure updates in a nutshell. For the next section, it's going to be table work, and I'm going to run this because I don't remember how long it takes. So we can see things are running right now. And let me hop back in here. For your purposes, afterwards, I do have a recap here that shows for each one of the things that we talk about, the phases and the process, what we're going to do during that point in time. I won't go through these in any detail because we're talking through them in the scripts themselves, but just as a reference for later. So next up, we're going to talk about table changes and hit several scenarios in here. So let's come back to the demo. Looks like we're done. What have we done here? Let's find out what it is that we've done. And first thing I did was create a large table. Into this large table, I added 4 million rows. So that is a large table that has a primary key constraint on ID, which is an integer, identity integer. I've also created a large heap that still uses ID as an identity integer, but has a non-clustered primary key constraint on ID. And I inserted 4 million rows in there as well. Now I also created a procedure that gets random records. So if I run this thing, it's going to scan through the entire table and return back 1,000 rows. So you can see it takes about 1 to 2 seconds to get this data, and there's nothing exciting in this data set, but it'll force a scan, and what it does is keeps us honest. So we'll be able to tell if there's any blocking. All right, so I've got a table. I want to add a column, some nullable column. If I have a null capability, then this is a metadata operation. As of, I believe that was that might have been as of SQL Server 2012. Some of this stuff, if you're using 2008 R2 and earlier, will not be metadata only operations. All of this as of about 2012 has stayed the same. So this guidance is anybody who's using SQL Server that's still supported. So I have a nullable column. We're good. Just add it. I have a non-nullable column, but I include a default constraint. So I include the constraint on the alter table definition. And if I do that, we can just add it. It is a metadata operation as of 2012. Older versions of SQL Server, my recollection is that this was not a metadata operation, that it would actually update the pages, and that would take a table lock. But when I say a metadata operation, we're essentially taking an we're taking a schema lock on the table, and we're updating some of the system tables to indicate that there is some change to the structure of the table, but we don't have to modify the data itself. We don't have to modify any pages of the data, which means things are going to be very fast. This may be a few milliseconds to perform instead of what might take several hours, depending on how large that table is. So let's say I need a nullable column without a default constraint. So in the pre-release phase, I'm going to create that nullable column, some non-default column. So I've got non-default, and I want to update some non-default column to whatever it needs to be. And in this case, this might be an example where I need to merge together two tables. I have some data that's on an older table, and I need to move it over to a newer table. There are a few different ways that we can do this. In this case, I'm going to create a supporting index. So the supporting index is on large table, some non-default column. So it's on this this column that I just created, and it's going to include some column. So, all right, I'm going to run this, but I'm also going to say I need to call a large table get random records, because I want to show that ran beforehand. Let's create this index. Because I'm in developer edition of SQL Server, I can run this while the index is being created. So we can see the index is still being created. And the only time that this will block is for a very short amount of time when we are switching over the metadata. Basically, the create index operation does all of the heavy lifting first, and then it says, okay, now I need to lock the table metadata so that I can indicate that there's this new index available to it. And it's only at that point in time, after all of the work is done, that we take that schema lock and say, well, we need to do some blocking. So that last time around, it did take a couple more seconds. There was a little bit of blocking, but if I run this again, we're back to normal. Okay, so we have an index. And what I'm going to do is update dbo.large table, set some non-default column to the first 20 characters of some column. And if I happen to have fewer than 10,000 records updated in this last batch, I know I'm done, so I can break. So this is one example of writing a script. And what we're doing here, one, we're updating in a relatively small batch. By updating in a relatively small batch, each update operation, because I have an index to support the operation itself, is going to be fairly small. It's going to be fairly compact. The way that I wrote this query, where I said where some non-default column is null, that is my clustered index, or excuse me, my non-clustered index here. And so it's going to, at first, when the entire table is all null values, it can just pick, like, here's 10,000 rows. Doesn't matter which 10,000 rows. But as you get more and more of the values in that index filled, that I have a non-clustered index on here means I can still check, here is the section of the index where all of my nulls are versus all of my values. And that will still be a relatively fast operation because I can jump to the place in the index where all of the nulls are pretty quickly. I say this because sometimes if you write a query like this, and you don't have that supporting index, then the first few operations will be really fast, but then essentially what you're doing is you're scanning through the table until you've met this condition. So first time around, it's really fast because all of the columns meet this condition. But as you get further and further along, where you've got 3.5, nearly 4 million records updated, it can be very slow because I have to scan the entire table just to get to those last records. So in this case, our scan depth is pretty much constant the entire time. By the way, while I'm performing this update, took about 7 seconds there. A little bit of a degradation for a moment, but we can see, okay, yeah, it's still doing okay. We're performing our update. It is happening. I can even query large table and I can see some non-default column. I do see it is being populated. So this action, because I'm using recommitted snapshot isolation for this database, is non-blocking. It may be a performance hit while I'm in this pre-release phase, but at least it's not blocking. And I can have this operation run for however long it needs to be. That could be hours, it could be days. This is still just going to be able to run in the background. When we are totally done, then we can deploy any scripts that call the new column. So I can make any procedure changes. I can make any updates to the code that are going to use that new column that we've created. Application phase, we deploy application code that uses the new column. Database post-release phase, once we're done with this operation, we can drop the index if it still exists. So we see that it took a minute and a half. I can now drop the index because I don't need it. We've done all of our other stored procedure deployments. We've done all of our other work around this operation. Let's say I want to remove a column. Remove a column in the database post-release. Some nullable column, turns out we don't actually need it. The code doesn't call it. I can get rid of this column from the table. Alter table, drop that column. This is a metadata operation. If you want to restore that space, like let's say this is a fairly wide string column that doesn't go to the lob, I'll want to rebuild those indexes. If it does go to the lob, I'll still want to rebuild the indexes, but you may have to do more drastic measures to reclaim that space. Could be important if you have a lot of space that's used up by certain columns. But yeah, basically do this in the database post-release. Once you're sure that there's no code that's using this this column. Now I have a column with a default. So non-nullable column with default. If I have a default constraint, drop the constraint first, then drop the column. And everything works just fine. Let's say I have a string column. I have varchar in this case, and I want to extend the length of it. Well, if you are extending the length of a string in varchar or varchar column in SQL Server, again, at least as of 2012, that is a metadata operation. If you're extending a char, things get a little bit weirder, but fortunately, those cases are very rare where people will use char or nchar. So varchar extension, no problem. Let's say I want to shrink it. So I just extended it to 56 characters. And I haven't done any changes. All of the data, the maximum length of that data is still 50 characters. So if I want to shrink it, this should be a metadata operation too, right? The answer is no. It is definitely not a metadata operation, because even though I know that the maximum length of any record in there is 50 bytes, SQL Server doesn't know that, and therefore it needs to check. And if I were to run this, it would be blocking. It would be a blocking operation because it's going to lock the table to ensure that nobody can sneak in and put in something that's longer than 50 characters, and therefore break our new table. So for consistency's sake, it has to lock that table completely. So instead of making that change, which might lock us for a while, this is where things get a little painful, because instead of one line of code, which I could take during a downtime, I need to do a little bit more work. In the database pre-release phase, we're going to add a new column, some other column too, that is varchar 50. So I've created that, and then I'll add an index on some other column where some other column 2 is null. So this is a second way of writing an index. And I wanted to include both of these styles because they can both make sense in different circumstances. So in the original circumstance, I had a new column, and I had the new column as the non-clustered index and the old column as an include. Here, I say use a filtered index where some other column 2 is null, and include some other column as our sort criterion. Both are valid ways of writing a query. In this case, I decided to go with this route here because I knew that some other column is not really nullable. I'm going to have legitimate values for all of them, and my filtered index will allow me, it'll gracefully funnel down the number of records that are still applicable to the index. Because I'm creating this index online, in the process of creating the index, it's not going to block anything until the very end where I need to take that schema lock and index metadata gets updated. saying, hey, here's a new index for you. Next thing, I'm going to create a trigger. This trigger on the large table after insert or update is going to update some other column 2 and set it equal to some other column. The reason why I'm doing this is the application doesn't know about this new column yet. So any inserts to the table are just going to insert to some other column. If I completely control insert operations using stored procedures, and I completely control update operations using stored procedures, I could update the stored procedure code and write to both. But I'm going to assume that I can't completely control it. There might be some SQL agent job that's doing ad hoc updates. There might be some DBA who's doing ad hoc updates. Because there's that risk of some update operation sneaking in that doesn't handle both columns, I'm going to create this trigger. And just to make sure that the trigger works as expected, let's insert into dbo.large table some column and some other column. So I don't have the 2, but we can see some other column 2 does in fact get the values from some column. Or from, from some other column. If I do an update, I do want to indicate that updates are going to work just as we expect. So we're keeping these 2 columns, some other column 2, in sync with one another. And then I can start updating the records. So this could be a SQL agent job that runs, and maybe we're running it during low periods of the day when things are a bit slower. Maybe we decide to run it whenever that, because hey, I can still query dbo.large table. I can still get random records. Everything's still running. If I can handle this degradation during the course of the day, no big deal. But this may take a while. This may take days, and that's okay. Once we are done, once we do have things in sync, when this is going to not return any records updated, because we still have this trigger in place, anything that people are inserting in the process along the way is still staying in sync. So we're safe to deploy whenever, once this query is done. Once it's done, we can deploy any new procedures. We can do anything we need to do in order to use that new column. Then we can deploy our application code that uses the new column. Or here's an alternative. I have some other column 2. Well, I don't really want some other column 2 to be queried. I want it to be called some other column. So what I can do here is drop the index, drop the trigger. And I'm doing this in a transaction. Because I'm doing this in a transaction, I'm going to, with drop index, take a lock on the table. It's a schema lock on the table. I'm going to drop the trigger. I'm going to alter the table and drop some other column. And then I'm going to rename some other column 2 to some other column. Why this makes sense is that any existing procedure is going to look for some other column. Any existing ad hoc code is going to look for some other column. And right now, I have this get random records that looks for some other column. If I query the table, I can see that I've got this some other column 2. Over here, let's begin our transaction, and we'll drop our index. You can see we're being locked. So can't see anything here because I've got that lock. Now if I continue the process, let's. Oh, Azure Data Studio, why you got to do this to me? Ah, see, I wanted to do the whole thing in Azure Data Studio, and here it is going crazy on me. So let me open up Management Studio and clear things out. Be just a moment with this. You know what, might as well bring over Management Studio here. Let's see what's going on. Oh, I don't have who is active. Oh no, that's kind of a horrible person am I? Ah, all right. So break that connection, break that connection, break that connection. See if I can come in. I'm probably going to need to kill a few commands here to get this working again. Kill 152. Kill 250. There we go. Okay, so that was canceled. And I should be able to reopen Azure Data Studio, and hopefully it won't complain this time. Let's open this folder, approaching 0 scripts. And I'm just going to do this as one constant operation so that Azure Data Studio doesn't go crazy again. So we're going to drop the index, drop the trigger, drop the column, rename some other column 2 to some other column. And what the benefit of doing it this way is that because I've got that schema lock, as soon as we drop the index, nobody's going to be able to access that table. So there's no case in which someone will try to select top 1000 star from DB large table and will get a circumstance in which they don't have some other column. So every call to that is going to give you back some other column. The question is, do you get back the varchar 50 version or the varchar 56 version? And the answer is, as soon as I begin this transaction, drop this index, you're going to get back the 56, or excuse me, the varchar 50 version, the one that has been shrunk, which is the one that we want to give back. If I want to rename a table, this is something that can happen during the database release phase. So let's say I have test large table. I rename dbo.large table to test large table, but all of my current code is expecting dbo.large table. So I can create a view large table that is essentially select star from the new table name. And if I do this as one transaction, then it's all just metadata operations. And therefore, right now, everybody can still query dbo.large table and still get back the same results. I deploy any new procedures to call dbo.test large table. I deploy new application code if there's ad hoc queries that hit dbo.large table, and I can drop that view. So once everything is using the new table name, I can drop the view. And we're going to clean up, rename that back for later scripts. So let's close all of these. Close all except that one. And start working on indexes. If I create an index on a column with Enterprise Edition, basically the upshot of this is I take a schema lock at the very end when the index is created and when we're ready to switch it in and allow table queries to use this. So there's very short locking at the very end of this. Dropping an index, something you can do in standard edition. Again, metadata only. Creating an index like this, you could create it in standard edition, but because we cannot use online equals on, it is going to lock during that time frame. So that is something that is Enterprise Edition will make your life easier in that regard. New clustered index. If you've got the disk space, you can do this as an online operation, but you'll need roughly twice the disk space for the index. So what do I mean? If I have a large heap, so I currently have a heap and I'm going to create a clustered index on some column, I will still have the heap that is accessible throughout the course of this operation while I am behind the scenes building the new clustered index that contains some column. That's going to require enough disk space for the heap table as well as the clustered index version. And once we're ready, we can switch over quietly and have our new clustered index. But until that point, I'm going to have both versions of this table running and loading in sync. Just like my examples where I had backfill tables. It's just that this time SQL Server's handling it all behind the scenes. But I am going to, during this time frame, need more disk space than what I'll need after the fact. So let that continue running and look at a clustered index, which is not a primary key constraint. So in my database pre-release, I'm going to check to see if I do have CIX large heap. And if I don't have it, then we're going to create it on some other column. I do have CIX large heap that I'm just creating here on some column. And this says if it's not on some other column, then go ahead and create it. So again, when it's not the primary key, you can change a clustered index online with Enterprise Edition. And there's the only downtime is that metadata lock at the very end. But you will require twice as much disk space. What if it is the primary key constraint? Well, this should be fast. I have large table, I drop the constraint, I add the constraint to make it non-clustered. This is not actually that fast. So it will take a little while, but it can be an online operation. This dropping the constraint and making it non-clustered can take some time. So because I am, speaking of time, I am just about out. Let's zoom through this here and say there are index changes, there are constraint changes as well. Those constraint changes, basically, if you're working with default, or if you're working with something like a check constraint or a default constraint, then you can do things like a default constraint. You can do these just inline. Pre-release, create that constraint, no big deal. Post-release, go ahead and drop the thing, no big deal. But for other constraints like checks, primary keys, these things will block. Foreign key constraints will block. So best solution, build a new table with those constraints and get it right on that new table. So as we're wrapping up, I'm going to jump over to the last slide where we learned today that zero downtime may not be for every company. If you do have the ability to take downtime, it does make your life a lot easier. If you don't have the ability to get those downtimes, and you do need these tools, it is a good idea to know what you can safely do without blocking customers. If you would like to get these slides, if you want to get scripts, demos, links to more resources, go to csmore.info/on/ZDT. If you have any questions at all, please do feel free to reach out to me. My email address and Twitter handle are on the screen here. And If there are any really quick questions, looks like we have a slight amount of time, just a few seconds for them. But I
Yes,
want to say
we
thank
have
you
two
so much.
questions.
Okay.
We have two questions from the online audience. First is, how would you approach deployment with costly operations, like convert varchar column to nvarchar, about 20 minutes downtime, and then 50 gigabytes of data transfer between live queried tables, assuming you have no availability groups?
Yep. Okay. So in that case, I would follow the pattern where I showed create the new table and then, or excuse me, create the new column. Create the new column, create a process to migrate old column to new column, varchar to varchar, and create a trigger to ensure that new records will be in sync. Have that process run for however long it takes. Yes, you're going to have the extra space requirements during that time frame. Once you're done, lock the table, rename the columns, or drop the old column, rename the new column, and then your code now knows that hey, this is just in varchar. That's if you want to keep that same column name. If you're okay with using the new column name, at that point, drop the old varchar column. And make sure that your procedures and code recognize the new name.
Okay, thank you. And second question, how do you keep your code in the repo? Are you using state-based approach like SSDT, or maybe migration-based like in Flyway, or maybe something hybrid, custom?
Yeah, that's a really good question. The answer is in our case we kind of use both. We use a migration based approach for generating release scripts, and then after the fact, there's a PowerShell script that goes and pulls metadata out from the databases and stores it as a state version of what our code base looks like. So that way you get the state-based advantage of knowing here is what a procedure looks like today while writing the release-based migration process.
Great, thank you. And last question popped up. I see that it is migration script mostly used in your demo, but I wonder how do you keep track of changes to deploy, order which scripts are in each release and so on?
Yeah, basically the process that we use is to have each operation associated with a story. So there's a Jira ticket that is included, and the release folder has basically one folder for every Jira ticket. The automated process picks those up when the Jira tickets are in a certain state, does the deployment to whatever environments it needs to, and for our code that's in source control, we're going to have the migration scripts themselves, but also that PowerShell operation, which goes and reads, say, sys.sql modules or sys.tables and generates the underlying table or procedure definition for us to look at later.
Okay, great, thanks. I hope this answers the questions. So thanks again for showing up, and thank you for the session.
And thank
Hopefully
you,
to see you
everybody.
live.
All right.